Welcome to DevOps Corner. You ever been there? You're a developer, maybe working on the UI, and all you want to do is run a couple of backend services just to test a new button. But instead of a quick 5-minute check, you're suddenly wrestling with a full-blown Kubernetes cluster on your own laptop. Yeah, it feels like you're being asked to build a skyscraper just to hang a picture frame. That frustration, it's totally real. And it points to this huge misunderstanding in the DevOps world about two really essential tools, Docker Compose and Kubernetes. A lot of people see them as rivals, like you gotta pick a side. But the truth is, the smartest teams don't choose. They use both. All right, let's just paint the picture here. Imagine you're that UI developer. You've just built this awesome new feature. And to see if it even works, you have to connect to the main API and a database. Should be simple, right? But wait, these services are all separate containers. So in a world before we had better tools, your simple little task just blew up into a major infrastructure project right there on your own machine. And this is what that old, painful way looked like. I mean, first you'd have to manually create a Docker network just so the containers could even talk to each other. Then you'd have to write out these monster Docker run commands for every single service. One for the database, another for the backend, each one with like a dozen flags for environment variables, port mappings, linking them to that network you just made. Ugh. And if you get just one flag wrong, you're spending the next hour debugging your local setup instead of your actual code. It's so tedious, it's error-prone, and it just completely kills your flow. It's the question every single developer in that spot asks themselves. You're just trying to write code, not become a systems administrator for your own laptop, right? There has to be a tool that's actually designed for the developer, one that puts speed and simplicity first for exactly these kinds of scenarios. And of course, there is. And that elegant answer is Docker Compose. This is the tool that basically says, hey, I get it. I see your pain. Let's make this easy. It's designed specifically to define and run multi-container applications, and it turns that command line nightmare into a single, simple action. Think of it as your personal, portable development environment, all defined in just one file. So what is Docker Compose, really? Well, at its core, it's just a recipe, a single, human-readable YAML file that describes your entire local setup. You define your services, your networks, your volumes, all in one place. Its sweet spot is right there on your machine for development and for testing. It's not trying to run the entire internet. It's just trying to make your day-to-day life a whole lot easier. And the workflow? Oh, it is a breath of fresh air. It's this simple. First, you create one file, dockercompose.yaml. Inside, you just define your services. Maybe a front end, a back end, a database. You tell it what image to use for each, the ports, any dependencies, and then the magic. You just go to your terminal and type one command, Docker Compose up. And that's it. Docker Compose reads your file, creates the network for you, pulls the images, and starts everything up in the right order. Your entire application stock is up and running, just like that.
The benefits here for a dev team are just undeniable. The setup is incredibly fast, and its main selling point is just pure simplicity. It is the perfect tool for creating these ideal little local development sandboxes. I mean, think about onboarding a new engineer. Instead of giving them this multi-day setup guide, they just run Docker Compose up and they are ready to contribute code in minutes. And here's a huge advantage. A UI developer can have a Compose file that only runs the UI and the API, completely abstracting away the dozen other microservices they don't need to care about. It creates these isolated, repeatable environments that are perfectly consistent for every single developer on the team.
But local development is a nice, calm, controlled world. Production is not. Production is chaotic. It involves massive scale, totally unpredictable traffic, and the absolute non-negotiable requirement that your application never, ever goes down. See, managing a handful of containers on your laptop is one thing. Managing thousands of them across a whole fleet of servers, that's a completely different beast. And for that, you need a powerhouse. And this brings us to Kubernetes, or K8 as you'll hear it called. Now, this isn't just a tool. It's a full-on platform. It's an orchestrator. Its entire reason for being is to automate the deployment, the scaling, and the management of containerized apps at a massive scale. It doesn't think in terms of a single machine. It thinks in terms of a whole cluster of machines, distributing the work and providing a level of resilience that's just impossible on a single host. Let's make this really concrete. Imagine one of your application's containers crashes. If you're using Docker Compose, yeah, you can configure it to automatically restart that container. And that's helpful.
But what if the Docker engine itself crashes? Or the whole machine goes offline? You're out of luck. Kubernetes, on the other hand, operates on a whole other level. It's constantly watching the health of your containers. If one fails, it doesn't just restart it. It instantly spins up a brand new replacement on a completely different, healthy machine in the cluster, all without a human lifting a finger. That is true self-healing.
Okay, now let's talk about a traffic spike. With Docker Compose, you could manually use a scale flag to spin up a few more copies of your web server container, but they're all still stuck on that one single machine, all fighting for the same CPU and memory. Kubernetes is built for this. You can configure it to watch things like CPU usage. When traffic surges, it automatically scales out, adding more copies of your containers across all the available machines in your cluster. It can even add new machines to the cluster if it has to. And then, when the traffic dies down, it scales everything back down. That is true elastic automated scaling. So what we have is this simple, developer-friendly tool and this complex production-grade powerhouse. And this is right where the misconception lives, that you have to pick one. But this isn't a competition. This is about partnership. The real aha moment comes when you realize they were designed for different stages of the software lifecycle, and they actually work together perfectly. And this right here is the secret that highly productive engineering teams have all figured out. It's not a compromise, it's a strategy. They use the simplicity and speed of Docker Compose for all of their local development, which empowers their developers to work fast and efficiently. And at the same time, they use the power and resilience of Kubernetes to run that same application in production. The tools don't conflict, they complement each other. So what does this modern workflow actually look like day to day? Well, a developer pulls the latest code, they run Docker Compose up on their machine to spin up only the services they need to get their job done. They write their code, they test it, and when they're done, they push it to Git. That push triggers an automated process, a CI/CD pipeline. That pipeline takes their code, builds a fresh Docker image, and pushes that image to a central container registry. The final step is that the pipeline signals to the production Kubernetes cluster to pull that new image and deploy it. The developer never even had to touch Kubernetes, but their work ends up there, seamlessly. And hey, if this idea of how these tools fit together is clicking for you, if it's helping you think about making smarter infrastructure decisions for your own projects, maybe take a second to like this and subscribe for more deep dives into DevOps topics. It really does help us create more content just like this. It's also really important to remember that infrastructure choices aren't set in stone. The right choice on day one might not be the right choice in year two. Smart architectures evolve right along with the needs of the product in the business. And this Compose to Kubernetes path is a perfect example of that kind of evolution. Let's just follow a hypothetical startup. On day one, they're launching their MVP, their minimum viable product. They've got 2 developers. They can actually run their entire application in production on a single server using, you guessed it, Docker Compose. It's simple, it's fast, and it gets them to market. Okay, by year 1, they have traction and traffic is growing. That single server isn't going to cut it anymore. So they migrate their production environment over to a managed Kubernetes service to get that critical scalability and high availability. Now, let's fast forward to year 2. The company's a huge success. They're running a massive complex Kubernetes cluster in production. And what are their 100+ developers using every single day on their laptops? Docker Compose, because it's still the fastest, simplest way for them to do their daily work. So it all just boils down to one of the core ideas of good engineering, using the right tool for the right job. So let's create a really clear, practical summary to make sure we know exactly when to reach for each of these tools in our toolbox. This really breaks it down perfectly. For local development and testing, it's Docker Compose, no question. The reasons are obvious: simplicity, speed, low resource usage on your own machine. Onboarding new developers and getting them productive fast? Docker Compose, all day for that one command setup. But when you're running a production web application that absolutely needs to be up 24/7, that's Kubernetes territory for its high availability, auto-scaling, and self-healing. And managing a complex web of microservices at scale? Again, that's Kubernetes for its advanced networking and service discovery. And this really gets to the core guiding principle that we should all try to follow. Don't over-engineer. Don't reach for the most complex, powerful tool just because it's popular. Choose the simplest tool that actually solves the problem you have right now. Start with Compose, get your idea working, and only evolve to a more complex system like Kubernetes when the problems of scale and reliability make it absolutely necessary. So let's just reframe this whole debate. The next time you or your team kicks off a new project, the question shouldn't be a choice between one or the other. It is not Docker Compose versus Kubernetes. The real strategic question you should be asking is, what will our workflow look like? And how are we going to use these two powerful complementary tools together to make our developers fast and our production systems unbreakable? That is the path to building great software. Thanks so much for joining us on DevOps Corner. If you enjoyed this deep dive and it helped things click for you, be sure to hit that like button and subscribe for more explainers that break down how modern infrastructure really works. Thanks for watching.